Hello, Haripriya.
Hi, sir.
So today we'll be starting thermodynamics. Okay, let's start. Let me start with the basics of thermodynamics. Then we'll move on to the complex processes, and then we'll be solving the problems. Then, okay. Now, wait. Now, what is thermodynamics? Thermodynamics is the dynamics of heat exchange. In this, we actually study about the heat exchange between the two processes, different processes. Now, before we start to learn about these, we should actually learn its basic characteristics and basic things that we'll be constantly using or constantly talking about. First, we'll learn about the types of systems. Systems are of three types. First is open system. Second is closed system. Third is isolated system. Before this, let us learn about what is a system and what is surrounding. See, what is system, surrounding, and what is boundary? Whenever we have, suppose you have taken a space and you have drawn a boundary around it. Boundary means you have made the boundary inside which there is something which you are studying, rest all things are surrounding. So this is known as your boundary, which separates system from the surrounding. The inside thing is system, outside is surrounding. Now there are three different types of system: open system, closed system, and isolated system. How they are defined? On the basis of systems are defined on the basis of energy and mass exchange. Open system is that kind of system in which exchange of both energy and mass takes place. Okay. What is a closed system? Energy exchange take place, but no mass exchange. In a closed system, energy can exchange between the system and surrounding, but mass cannot exchange. Mass cannot move out from the system to the surrounding or from the surrounding to the system. In open system, both energy and mass can move out or come in. In the isolated system, no energy, no mass exchange can take place. Okay, these are three types of systems. Basic things are there. Just that's why we are reading it. These are basic things. Now let me define few more things. Functions, type of functions. These are not mathematical functions, they are thermodynamic functions. Function are two types. Point function and path function. What are point functions?
There is point function and state function is the same thing.
Point function and state function. They both are same. Both are same. Point function is also known as state function. Point function actually depends only on the initial and final points.
Good evening, sir. Happy New Year, sir.
Same to you. Happy New Year, Kanishka. Happy New Year, Haripriya. I not tell you. How did you celebrate?
Happy New Year, sir.
How
I
did you?
just cut a cake this morning. That's it.
Wow, good. What about you, Kanishka?
Sorry, nothing special. Just yesterday I went to the mall with my family.
Nothing special. You did not do anything. Should have
So not
ate.
today, yesterday I went.
Acha,
That's why
where?
I wasn't able to join that.
Acha. Yesterday you went. That's why you are not able to join. Okay,
Yes,
okay.
sir.
Today you did not do anything.
No, sir.
So you woke up till 12 p.m. 12 a.m. Sorry.
No, sir. I woke up at like 8 a.m.
Acha, what you are doing? Watching some this one celebrations going on in your colony or somewhere.
Yes, sir. I was watching that only.
It's very common actually. Most of
At
the
12 p.m., everyone was like bursting up the crackers here in our side.
huh, what I did now in the evening. In the evening, I was saying to Haripriya that something I'll watch. I watch one movie. One movie is there, not Netflix. It's Baramulla. Baramulla. That movie I watched, and then what one mistake I did. That mistake was, even though I ordered pizza, I was eating it, but it's a practice that whenever we eat pizza, we drink somewhat Pepsi or something like that. That fellow, the Domino's one, that fellow, I don't know, there was an offer or something. He brought Pepsi along with it. Now, what my mistake was, I should not have drank that Pepsi because it was cold and it is very cold here. Kanishka must be knowing it.
Yes, sir.
It's very
very
cold
cold.
because sun is
I
not there,
sleep
na?
on my blanket only.
It's very cold. And what my mistake was, I could not resist myself. I drank that Pepsi. Small one. Small one only, I drank it. And the problem, and then in the night, the cold, I got cold. From morning, my nose was blocked. Even though I took some classes, but my nose was blocked. I was not good. But I did not want to skip your classes. Now I'm somewhat better. That's why we should be very careful, otherwise time get wasted. Usually I avoid sugary foods, sugar, these Pepsi, I never drink. But I should have thought it's cold. In the cold, if you are having the urge to drink that Pepsi or something, you should not drink it at all because it's too cold. See, that's why I'm drinking haldi milk.
Actually, we celebrated in college today, sir, after our exams.
What did you do?
Like our fellow batchmates had ordered cake. They went and bought cake along with chips and some cool
Oh.
drinks.
So you drank cold drink.
Yeah, today.
But see, at your place, it's not that cold, no? Temperature won't be that much. How is that the weather there?
Sir, it's relatively cold, but it has improved like for past 2 days. It's now raining.
That means you have better immunity than me. I need to improve my immunity. Even though I take care, I sit in the sun for some time, take vitamin D, I check all my parameters, I do exercise. But then also my immunity is down, I think. That's why. Otherwise, this thing should not have happened. Because I don't want to waste your time. Your time is precious. See, point functions, path functions. Point function is depend only on the initial and final points. Path function is the process. It's the process. There's one more thing I wanted to tell you. Start giving mock test. See, the more you start early, the mock test that I am providing in the app, start giving them. Whenever I give it, do it. Attempt it. Because it takes time to improve. Even though you may be knowing the concepts, you may be feeling confident that sir is teaching, we are able to understand everything, we are able to solve questions in the class also. So gradually our level is increasing. But that does not make sure that you will be able to do the questions in the examination hall with the speed. Because you have to solve the questions in a fixed amount of time. 1 hour, 25 questions are there. At least you should make the habit of solving 15 to 16 problems per hour. So that only comes when you solve questions in time period. So make a habit of giving mock test. It's not full syllabus, I'm not suggesting you, but the topic wise test that I give you in the applications app and all, that never miss them. Even though, see, you may be having examination at your school, I know it may become hectic and you may be thinking that I'll relax somewhat and then I'll give the mock test when all things are over. But that practice is not good. The right practice is study, practice, with that do the mock test also. And after mock test, analyze your mistakes, where you're lacking, what is decreasing your speed, why you're not able to maintain fast speed. Is it your calculation speed is low? Are you doing silly mistakes, or are you lacking the conceptual applications? Do analyze it accordingly, work upon your weaknesses, and then improve it. Earlier you do this, it will be much easier for you to get into IIT. Understood? This is only difference between the topper and an average student. So what is point function? Depends only on the process, depends on the initial and final points. Path function depends on the path rather than the points. I'll give you an example. Suppose point function examples are pressure, volume, temperature, mostly. Gibbs function is also there. There are many different one. Process different. So pressure, volume, temperature, and Gibbs function. All these things are there. They are known as point function. Path function examples are work and E cell. E cell you may not be knowing by now, but later after you reach it to class 12, you will be able to know what is E cell. It's related with the electrochemistry. Okay. Now the main difference is, I'll give an example मैं दे देता हूँ. Suppose there are 2 points. This is A and this is B. There are 3 different paths. This, and this. This is path 1, this is path 2, this is path 3. If we talk about the path function, in path function, work done along the path 1 will not be equal to work done along the path 2. It will not be equal to work done along the path 3. Because paths are different. Delta W1 I may say. But if we talk about the point functions, point function means, let's say I have taken pressure. P1 here is P2. Or where V1 volume is V2. So if I ask you to calculate the difference of pressure delta P, it will be simply P2 minus P1. Does not matter whatever path you move. You move along path 1, 2 or 3, still the pressure difference will be P2 minus P1 only. Delta V, it will be V2 minus V1 only. Delta T, it will be T2 minus T1 only. So this is the difference between the point function and the path function. Easy? One more thing I would like to tell you. I will tell you something about the work. The more detailed things I'll tell you later. But let me tell you what is work. By now, you know, through work power energy, work is force into displacement. Okay. Now, but here in thermodynamics, you won't be having force and displacements. We'll be talking about pressure and volumes. So we can write this work as force per unit area into dx. Now I can actually write force per unit area as pressure, A dx is PV, volume, change in volume. Clear? It's like, suppose I have a cylinder. This is the area. This is the force which is applied. This is the area. This is the length dx, for which we have displaced this area. So work, what I want to tell you is, work is force into displacement, but work can also be written as PdV. Okay. Now I don't know whether you remember that concept that I've told you. Can you tell me what's the area under VT curve? Do you remember that one? Haripriya, Diva, sorry, Haripriya, Kanishka. What's the area under VT curve? I told you in the kinematics only, first one.
Volume and time, no, sir.
No. Velocity and time.
There it would be distance.
Distance, na? Correct. How do we know it? Because we have a concept that, if you remember, I told you, whenever there is a curve, like this, it's y is equal to f of x. This is x-axis, this is y-axis. Then area under that curve, this area is given by a is equal to integral y dx from x1 to x2. That's the concept. One more concept is, if you take it along the y-axis, this area A2 is integral x dy. That concept you remember now? This is actually, this concept you will be learning in class 12, which is area under the curve, that chapter. But since it is being used in your kinematics and all, I have already told you, you should, I'm just trying to recollect for you. Okay. Now, why I am telling this? Because we want to find out work done. If I have a PV curve, like we know area x1 to x2 y dx is the area. Now, if I have the PV curve, can I write the area under the PV curve, which will be, this area will be, area is equal to integral P dV. I can write now.
Yes, sir.
And what is that P dV, integral P dV? Integral P dV from this is what? It's the total work done, W. So what I am trying to say, area under PV curve gives work done. Clear? This is a concept. Understood? Now let me give you some question. See, one very easy question I'll give you. Try this.
Said 48
Uh,
joules.
correct. Very good. You have to just find out the area because the concept I have told you. Area you will calculate. This area is 8 into 8, and this area will be half into 4 into 8. 16 plus 64. What is this? Where I'm doing wrong?
So the starting is 2,2.
Yes. See? Silly. I also do silly mistakes. 8 minus 2. This is 6. This is 6 and this is 6. Very good. 6 into 6. And this area is half into 6 into 4. 12. 36. 36 plus 12. Total area is 36 plus 12, which is 48. Very good. Even though it was easy, but good observation. That 2, 2 is there. Most of the students will be doing this mistake only that I did. Okay, let's move on. What about you, Kanishka? You did not?
Yes, sir.
Okay. Now let me tell you about properties. There are two different type of properties in thermodynamics. One is intensive property. The other is extensive property. What's the difference? Intensive properties are independent of mass. I'll give you the example, don't worry. Actually, whenever they give you small questions, they actually give ask questions like that. Which of the following is an intensive property? Which of the following is an extensive property? They'll give you the 4 options. Then you have to, by your knowledge or experience, you have to click the right answer. These are the properties which are dependent on mass. Simple. I'll give you the example. Extensive is one is mass. Second is volume. Volume is also dependent. Okay. G, Gibbs energy. Gibbs function. Gibbs function you will be learning later. Now I have not introduced you about Gibbs function. Gibbs function is a function actually which determines the spontaneity of a reaction. What is the spontaneity of a reaction? Whether a reaction will move forward or a process will move forward or not, that is actually known by the value of Gibbs function, G. If it is negative, it will move forward. If it is positive, it won't move. If it is 0, the process is in equilibrium. Let me tell you this. Delta G is less than 0. Spontaneous process. Delta G is greater than 0. Non-spontaneous. Non-spontaneous means it cannot move forward. Delta G equal to 0. Process is in equilibrium. Equilibrium you should have studied by now. What is equilibrium process? There is actually a relation delta G is equal to delta H minus d delta S that I'll tell you later, don't worry. This Gibbs function, because why I am saying this Gibbs function is actually extensive, because Gibbs function represents energy. And if you know energy, E is equal to mc square is there. That relation, energy mass equivalence, which changes, which governs how much energy will be released if some amount of mass is destroyed. So it's dependent on mass. That's why Gibbs function is extensive. Now S is entropy. Entropy, I'll tell you later. What is entropy? I'll just tell. Entropy is the degree of disorderness. Later you will learn about it. Means more disordered processes, more is its entropy. There is a formula for it, delta Q by T, Q reversible by T. Since entropy formula depends on the energy, delta Q, that's why it is extensive. Now, next is enthalpy. Enthalpy is actually energy only, kind of energy which we represent in physics. That's why it is mass dependent. Next is heat capacity, that you will be learning in heat and mass transfer. These are extensive things. Now coming to intensive are first is density. Now you must be thinking, sir, density is mass per unit volume. Why it is independent of mass? Now since I said mass and volume, they both are extensive. Density is mass per unit volume, mass by volume. So mass is extensive, volume is extensive. You divide it, both will be cancelling each other, so it becomes intensive. That's why. Second is temperature. Temperature is also intensive. That is mu, refractive index. You know about refractive index now? Optics, somewhat you have studied in 10th class. Property of medium for light. Magnetic permeability. Permittivity. This you will learn in electrostatics. Charges. Next is pressure. These all things are intensive, means independent of mass. These are some examples. Mostly these are only asked in the question, in the examination, and you have to choose from which of the following is the intensive, which of the following is extensive, and you have to tick the right answer. That's all only, just theoretical part. I've given you because you don't miss easy question. That's why. This was the theoretical part. Now, actual thermodynamics will start from here. Thermodynamics is governed by the laws of thermodynamics. There are actually 3 laws. First is zeroth law. Second is first law. First law is very important. Most of the problem solving you will be doing on the base of first law only. Second law of thermodynamics. Least important is the zeroth law of thermodynamics, but for the sake of understanding, we have to study it. Zeroth law. Acha, Kanishka, you may be knowing the zeroth law of thermodynamics because I think I have taught you. Can you tell me what zeroth law of thermodynamics? and C. And they say, according to the zeroth law of thermodynamics, if A is in thermal equilibrium with B and is also in thermal equilibrium with C, then B will be in thermal equilibrium with C. That's the statement. Let me explain you why. You will be studying later in heat and mass transfer. Whenever there are two bodies, TA and TB, the heat exchange is taking place. So the heat exchange takes place between the two bodies because of the difference of temperature. If TA is greater than TB, heat exchange will take place like MC delta T, which is TA minus TB. And TB is less than TA. So the heat it will absorb when it comes in contact with A, it will absorb heat. The value of, don't worry, you will study it in heat transfer. What is M? Mass of A. And we are talking about this mass of A. C is the heat capacity. If you don't understand, don't worry. Just remember, heat lost or gained is actually proportional to temperature difference between the two bodies. Now when there is no heat exchange, means I said A is in thermal equilibrium with B, no heat exchange is taking place. When it will happen? When temperature of A is equal to temperature of B, then only no heat exchange will take place, na? TA is equal to TB. Similarly, when A is in thermal equilibrium with C, that means TA should be equal to TC also. Now you have these two relations, TA is equal to TB and TA is equal to TC, then automatically I can say na, that TB will also be equal to TC. So that means B is in thermal equilibrium with C automatically. Understood? Simple. Actually, there are no applications of the zeroth law. It's waste law, not used much. Just tell me you understood it or not. Don't worry about this one, MC delta T. You will learn better this in heat and mass transfer. And I'll start that chapter. Haripriya, understood?
Yes, sir.
Okay. Kanishka, okay? Understood?
Yes, sir.
Okay, now we'll be starting the most important law. That's first law of thermodynamics. What is first law of thermodynamics? Statement is very important. First law of thermodynamics says delta Q is equal to delta U plus delta W. This is the statement. First law of thermodynamics. Now, what is delta Q? It's heat exchange. Between what? Between system and the surrounding. Always the exchange of heat is taking place between the system and the surrounding. We're talking about the system and surrounding. System can be anything. We do not know what it is. System can be anything. It will depend on the situation. What system you are trying to take. What is delta U? Delta U is the internal energy. Do you know something about internal energy? Haripriya, tell me.
It's like the total energy of a substance.
Correct. Internal energy is the total energy possessed by a body, and if I go deeper, inside a body there will be molecules, atoms, which will be colliding constantly with the surface, colliding with each other. So they'll have some kinetic energy, some potential energy, some vibrational energy, all those kinds of energy. So when you take the sum of all those kinds of energy, that's known as the internal energy of a system. Okay, and you will come to know later that delta U is actually constant. In kinetic theory of gases, they say it is NCV delta T. CV it, heat capacity at constant volume. It actually internal energy depends only on the temperature difference. It's very important. And what is delta W? Work done. These are the three things. But now let's first let me give you the sign convention. Sign conventions are also very important. Delta Q is said to be positive when heat is absorbed in system. This is the sign convention. It is negative when heat is expelled out from system. Out from or out of? Talking about delta U, I said it is NCV delta T, where N is number of moles of a gas. CV, I'll tell you, I'll give you the value of C for different type of gases, CP, CV and all. These values you should remember at least. There is a relation also, Cp minus Cv is equal to R, where Cp is the heat capacity at constant pressure. Need to take rest. You need to remember how you remember. Cv is 3R by 2. Only this value you should remember for a monatomic gas. Cp minus Cv is R, so it will be 5R by 2. Then the Cp of the monatomic gas is the Cv for diatomic gas, 5R by 2, and it is 7R by 2. 7R by 2, 9R by 2. Simple. You need to know only this value. Once you know this, you'll be able to get Cp. Then again, that Cp of the previous gas becomes the Cv of the coming gas. Then use Cp minus Cv is equal to R. So to get Cp of that, take the division Cp by Cv. You'll get 5 by 3, which is 1.4, 1.67. This is 7 by 5, 1.4. 9 by 7, 1.28. I wanted to give you one more thing. Sometimes one more formula is helpful for any other gas, any random gas. If degree of freedoms are given, do you know what is degree of freedom? Haripriya, Kanishka?
So, like, I just knew the values for monatomic and diatomic.
You do not know what is degree of freedom.
Like, they did it like yesterday and today.
See, what is degree of freedom, na? Degree of freedom is the number of independent motion that a gas can take. Suppose a monatomic gas is there, single atom. It can move in 3 directions, na? X, Y, Z. So that is why it has 3 degrees of freedom. In the diatomic gases, there will be different. It will be different, basing on vibration or spherical motion, like that. So degree of freedom is the number of independent motion a gas can take. Usually in the examination, they give you the degree of freedom of a gas. Using that, you will find out the gamma. And if they want to complicate things, now if you once you know the gamma, you can find out Cp and Cv also. I'll tell you, wait, how. Divide by Cv, Cp by Cv minus 1 is equal to R by Cv. Gamma minus 1 is equal to R by Cv. I have divided the first equation by Cv. So Cv is what? R by gamma minus 1. Now Cp is what? Cp minus Cv is equal to R is there. So Cp is equal to R plus Cv, which is R plus R by gamma minus 1. So you'll get gamma R by gamma minus 1. This is Cp value. Clear? Once you know gamma, you will be able to find out the Cp and Cv of any gas. But for the basic knowledge, you should know this table. You should be knowing this table. It's very helpful. I even told you how to remember this one. Very easy to remember, actually. Not difficult. As I was telling about, let me complete the sign convention. Internal energy is same, delta U. It depends on the temperature only. So there is no sign convention for this. Sign convention for work is very peculiar. You have to be careful here. I'll tell you physics and chemistry both. For physics, because we are learning physics, because you will be learning chemistry also, so you must know that also. For physics, work done by system is said to be positive. Work done on the system is negative. And reverse is for chemistry. Now you will say, why, sir? It's so. This is how they have done it. I don't know why they are doing it. It's very confusing. In chemistry, work done by system is negative, and on system is positive. So you have to be careful. Here in physics, you'll be using this one only. Okay, you have to be very careful in the examination. When the question of thermodynamics comes, the physics, work in solving questions, you have to apply work done by the system as positive, work done on the system as negative. When the same question is asked in chemistry, you have to take work done by the system as negative. So the calculation and the value of the answer will change. Okay, like that. Can you do this question? The 1 minute is left. Let me just list it out. From the next class, we'll be doing the questions. Let's end it today because I won't be able to continue. I'm actually very tired. Time is also over. This question you will solve. Try to solve it at home. If you're not able to solve it, I'll solve it in the class. It actually involves some knowledge of the gas laws. You should actually know the knowledge of gas laws. Gas laws, Boyle's law, Charles' law, Gay-Lussac law. That those laws are there, na? PV is equal to nRT. That knowledge you should have. Chemistry, I think you must be knowing this one. PV is equal to nRT. On the basis of that, you will be solving this kinds of question. Mostly, the question in thermodynamics will involve that knowledge of gas laws. Okay, let's end it. Rest will study in the next class. I'm not well. Bye bye. Good night.
Bye, sir.
Bye bye.